Hello and welcome to Unit 2. Here we're talking all about lines, angles, and triangles. And there are a number of terms that we are going to use quite often that we need to be reminded of. Adjacent angles are angles that are right next to each other. They actually share a line array. Parallel lines are lines that are on the same plane, but they never cross. They're going in exactly the same direction. Congruence means equal to in size and shape. Vertical angles are angles that are formed from two intersecting lines, and it doesn't matter what angle they're intersecting at. This angle always equals this angle, and this angle always equals this angle. Those are vertical angles. Complementary angles are two angles that when they're added together equal 90 degrees. And with supplementary angles, two angles that add together to make 180 degrees. And a transversal is when you have two lines that are going, they are coplanar, they're in the same plane, and you have a line that crosses them both. This line is called the transversal. Our first section, 4.1, starts with angles that are formed by intersecting lines. So first we have vertical angles, which we just discussed, where the measure of angle 1 is equal to the measure of angle 3 and angle 2 equals angle 4. Angle 1 plus angle 4 is 180 degrees because this is a linear pair, which means the outside line of both the angles is a straight line. So 1 plus 4 equals 180. 1 plus 2 is 180. 2 plus 3 is 103 plus 4 is 180. So angles formed by intersecting lines have all of these relationships. Then we have to be able to prove it. Can we prove the vertical angles theorem? And they're going to introduce to you a flow proof using a flow chart with arrows instead of boxes, so you can do parallel proofs, and that's something that we need for vertical angles. And it looks like this. So let's take this in sections, shall we? And it's really not as scary as it looks. We're going to start over here where we want to we're starting with vertical angles, and 1, 2, 3, 4, and we know that angle 1 and angle 3 are vertical angles. That's what we're given. So we're trying to prove, what are we trying to prove? We're trying to prove the vertical angle theorem, that opposite angles are all equal. So we know that angle 1 and angle 2 are a linear pair. That's given. We also know that angle 2 and angle 3 are a linear pair. That's given. So we're going to follow both of these the same way, which is why this is a more convenient type of proof. We know that because they're a linear pair, they're supplementary. That's what the linear pair theorem says. We also know that because of the definition of supplementary, if I add angle 1 and angle 2 together, I get 180 degrees. Same story here. Now that we've done both of those individually, we can come back to the same thing. Measure of angle 1 plus angle 2 is the same as the measure of angle 2 plus angle 3, because 1 and 3 are the same. That's the transitive property. Then we have that measure of angle 1 equals measure of angle 3 from just subtraction. So now we've proved congruence, the definition of congruence. So we've proven that if angle 1 and angle 3 are vertical angles, then they are also congruent. So please answer the questions, the reflection questions, numbers 4 and 5. Pause here and come back when you're done. And in the reflection, yes, it doesn't matter which pair of vertical angles are used in the proof. For number 4 and number 5, you've drawn 2, and you've told me that measure of A equals the measure of angle C and that B equals D, and you've measured them so that you know this. Next, we're going to actually use vertical angles. So here we have a diagram showing a set of intersecting lines with one angle marked as 146 degrees, and it asks you to find the measure of each angle. Well, based on the vertical angle theorem, you know that angle number 6 is also 146. You also know that this straight line is 180 degrees, so 180 minus 146 is going to give you the measure of angle 5, and it will also be the same for the measure of angle 7. Now, the proof of this angle is 146 because it was given. The measure of this angle is 146 because of vertical angles. That's because of vertical angles. Measure 5 is 180 minus 46 because it's a linear pair. And the measure of angle 7 is the same as measure of angle 5 because of vertical angles or because these two are a linear pair. You can choose. So pause here, try your turn numbers 6 and 7, and come back when you're done. Number 6, it gives this angle as 58 degrees, and it gives this angle as 3x plus 4 degrees. And so we know that because these two are equal, we can set these two number sets is equal to each other and then solve for x. X equals 18, and when we put that back in, 18 times 3 is 54, plus 4 is 58. So we know that it's true. But this asks for the value of x. This one, it sets these two equations, and I messed this up so I moved it over here. It sets these two equations equal to each other. So we're solving for x here, and here x equals 10. The next thing we're going to do is actually use supplementary and complementary angles. And if you have a hard time remembering the difference, remember that they're always alphabetical. So the first letter is also the first number. So complementary makes 90 degrees and supplementary makes 180 degrees. This problem that we have here asks us to find the missing angle measures and explain your reasoning. So we have line AD and line BE that cross at point F. We also have line FC that creates a 90-degree angle for angle CFD, and a 50-degree angle that's left over here, BFC, is 50. So it wants all of the angles. So the first thing it asks us to do is find angle AFC and AFB. Well, we know that AFC is a linear pair with CFD because this is a line. And if this is 90 degrees, then AFC is also going to be 90 degrees. So AFD is 180 degrees, it's a straight line. CFD is 90 degrees, that's given. AFC is there for also 90 degrees because it's a linear pair with CFD and because they are supplementary. And so BFC is 50 degrees, that's given. So AFB must equal 40 degrees because the total is 90 and this is 50, there are 40 left over. And that's either the definition of complementary angles or it's just subtraction. It also asks us to find DFE, this one, and AFE. Well, DFE and AFE are a linear pair. So we know that when we add the two together, they're going to equal 180 degrees. We know that BFA and DFE are vertical angles, therefore they're the same measure, vertical angles, which means that since this is 40 degrees, this is also going to be 40 degrees. And AFE and DFE are supplementary because they equal 180 degrees because they are a linear pair. And when you subtract 180 minus 40, you get 140 left over. And you can either use the definition of supplementary or the subtraction property here. So that's using proofs to get through working all of this out. So this is 140 degrees. So try your turn number 9 and 10 and then elaborate numbers 11 through 14 because we're almost done with this section. Your turn asks about the measure of an angle and its complement and the measure of an angle and its supplement, and it's asking us to work things out. So this one, the measure of an angle is equal to the measure of its complement. So the measure and the complement are the same. Now if we make the measure of this angle x, then the complement is going to be 90 minus x. And if we solve for x, 2x is 90, x equals 45 degrees. And then we go back and look for logic's sake, and that yes, if this is 45 degrees and that is 45 degrees, then they are complementary. They do add up to 90. On number 10, the measure of an angle is twice the measure of its supplement. So we're going to make this one x, and then we're going to make this one is going to be 2 times the supplement, which is 180 minus x. So we multiply that out, and then we solve for x, and 3x equals 360, and x equals 120. So we stick that back in there. And we say that 120 is 2 times the supplement, and then the supplement, 180 minus 120, the supplement would be 60, which multiplied by 2 equals 120. So that works. Then elaborate. Number 11, the theorem is more general and it explains the rules. Solving needs specific numbers, but both of them use logical steps to get you there. Number 12, both follow logical steps to the end. The plan allows for parallel paths and is less formal. Number 13, if we're looking at vertical angles, measure of angle A is congruent to C and B is congruent to D, and here is showing how they are all linear pairs. They are all supplementary. They all, when you add them up together, make 180. Number 14, angles in a linear pair add up to 180. So subtracting 180 minus the first angle will give you the second angle. Your homework for this is numbers 1 through 20, and please let me know if you have any questions. Thank you much.